Hello, everyone. Thank you for coming here today. My name is Chen Chen. I am a senior research fellow in the School of Civil and Environmental Engineering at Nanyang Technological University in Singapore. As you can see on the screen, our topic today is Singapore's sustainable built environment. First of all, I'd like to offer you a clear understanding of carbon. Next, I will discuss the carbon reduction method. Then, I will explain the green mark system. Finally, I will further give you an outlook on sustainable Singapore. Alright, let's start our first section. So, have you ever wondered what the greenhouse effect is and whether it's good or bad? Well, let me explain it to you in simple terms. It's a natural process that occurs when greenhouse gases in our atmosphere trap some of the heat from the planet's surface. Without this effect, the Earth would be too cold for living beings. However, human activities increase the amount of greenhouse gases in the atmosphere, especially carbon dioxide, which is the main greenhouse gas. This causes too much of the sun's energy to be trapped, leading to a warming effect that some people call global warming. We are not sure who came up with the term greenhouse effect, but some say that French mathematician Joseph Fourier coined it. Meanwhile, Irish physicist John Tyndall discovered the effect, and Swedish physicist Svante Arrhenius was the first to investigate it. It's crucial to understand the impact of the greenhouse effect on our planet and how our actions can contribute to its adverse effects. Have you had the chance to explore these magnificent structures on the NTU campus that showcase the university's commitment to sustainability? The Wave is an impressive timber building that serves as a sports and recreation center. The Hive is a versatile educational facility that stands out due to its striking architecture. It is also fondly referred to as the dancing basket building because its resemblance to steamer baskets used to contain dancing. The ADM, which is the academic building for the School of Art, Design and Media, is an architecture masterpiece with its sloped glass roofs that seamlessly blend in with NTU's garden campus setting. Lastly, the Gaia, Asia's largest timber building, is home to the Nanyang Business School. Understanding the meaning of net zero carbon buildings can be confusing. Essentially, the carbon footprint of a building is divided into two parts: operational carbon and embodied carbon. Operational carbon refers to the total carbon emissions from all energy sources used to maintain a comfortable indoor environment. Embodied carbon, on the other hand, refers to the carbon emissions generated throughout the life cycle of the building materials. If a building implements energy efficiency measures to reduce its operational carbon, it is considered energy efficient. If a building can generate enough renewable energy to meet its own annual energy consumption requirements, it is known as net zero energy. However, it may not be feasible for all building types and locations. In such cases, if renewable energy from off-site is imported to balance out the energy consumption, the building can be referred to as net zero operational carbon. If embodied carbon is also minimized, the building is known as net zero whole life carbon. Despite these efforts, there may still be residual carbon emissions that remain, which can be compensated by carbon credits purchased from the voluntary carbon market. By 2050, Singapore aims to achieve net zero embodied carbon for new buildings, infrastructure, and renovations, and net zero operational carbon for all buildings, including existing ones, in line with the global commitment to achieve net zero emissions. As we strive towards a sustainable future, it has become increasingly crucial for companies of all sizes to have a thorough understanding of the various sources of greenhouse gas emissions. These emissions are broadly categorized into three groups, namely Scope 1, Scope 2, and Scope 3 emissions. To elaborate, Scope 1 emissions refer to direct emissions that emanated from sources owned or controlled by the reporting company. Scope 2 emissions represent indirect emissions that result from purchased or acquired energy, such as electricity or heat. Finally, Scope 3 emissions encompass all indirect emissions that occur within the value chain of a reporting company. By gaining a comprehensive understanding of these emission sources, companies can better manage their impact on the environment and take steps forward in reducing their carbon footprint. There are two primary methods for calculating carbon emissions: the bottom-up method, also known as the process-based method, and the top-down method, also known as the input-output method. The bottom-up approach involves analyzing the carbon emissions of a specific building by aggregating its emissions at every stage of its life cycle according to established life cycle assessment procedures. On the other hand, the top-down method analyzes the total carbon emissions of the building sector using national statistical data. Building lifespans are generally over 75 years, which results in a very long time horizon for analysis. The majority of a building's embodied carbon occurs during the cradle-to-site phase, while operational carbon emissions are related to the usage phase. LCA consists of three steps. The first step involves defining the goal and scope of the LCA. The second step entails analyzing the LCA inventory. And the third step is to create the primary LCA results. Currently, LCA is predominantly used in a static manner. However, dynamic LCA takes time variations into consideration on various levels, resulting in significant differences between static and dynamic assessment. By distributing carbon emissions over time, the environmental impact is significantly reduced compared to if emissions were exerted all at once. An EPD, short for Environmental Product Declaration, is a document that has been verified by a third party and registered to show how products or services impact the environment. Even though EPDs in construction and manufacturing are optional, more and more people are using them as we become more aware of how our actions affect the environment. Different countries and regions have implemented various policies aimed at reducing embodied carbon. There are also many independent verifiers in the market, most of which are former inspection companies. There are numerous carbon footprint calculators available, with one-click LCA being the most popular. Nevertheless, it requires a payment subscription to use. Such calculators are typically built around the local LCI databases of their respective regions. To cater to the Singapore context, a dedicated carbon calculator for buildings was developed in the year 2022. When performing calculations, the data used is a combination of user-inputted company-specific data and publicly available data sources. These sources include country-specific data and country LCA data. Missing data problems can be alleviated by using extrapolated data and global median data. This slide provides a summary of the current gaps in carbon calculation. One issue is that carbon data comes in various formats, which makes analyzing it a tedious task. Additionally, the carbon emissions reported by many organizations and assessment tools are not real-time and lack verification. Next up, we'll be talking about carbon reduction. Have you heard about Building Information Modeling, or BIM? It's becoming more and more popular in the architecture, engineering, and construction industry. The difference between BIM and 3D CAD is that BIM files are much more detailed and have a lot more information. As a project progresses, the level of detail in a BIM file increases. There are 6 commonly recognized LOD levels in the industry, ranging from LOD 100 to LOD 500. A detailed design project often corresponds to LOD 300. So, as you know, the best chance to reduce embodied carbon is during the early design stage, when different design options can be compared. But keep in mind that conducting LCA based on low LOD levels can be challenging due to the many uncertainties involved. Creating a public database that stores accurate and comprehensive carbon data of existing buildings can prove to be a valuable tool in assessing and analyzing various design options. BIM and LCA come from 2 different domains, so they have their own unique software. People are talking a lot about their integration. There are 2 main approaches to achieving it. The first approach is to extract the building data from BIM software and transfer it to LCA software. The second approach is to create an LCA plugin in the BIM software. It's pretty clear that the second way is more convenient. This is a list of 9 different building materials and how much carbon each one emits. Rammed earth is the most environmentally friendly because it only uses natural materials like earth, lime, chalk, and gravel. Softwood timber is the second most sustainable building material. Glass, steel, and aluminum are the least sustainable, but they are used the most in the construction industry. When you explore Singapore, you may notice these technologies. Singapore is now one of the most solar-dense cities in the world. Singapore's architectural landscape also stands out with its remarkable green building envelope. Moreover, modern office and commercial buildings in Singapore have integrated innovative engineering solutions like underfloor air distribution and building control systems to bolster their energy efficiency and sustainability. Over the years, Singapore has seen a steady rise in its total electricity consumption. Currently, natural gas accounts for about 95% of Singapore's electricity generation, with most of it being imported from neighboring countries such as Malaysia and Indonesia. Singapore's geographical location on the equator and lack of access to hydro or wind power means that solar energy is the most feasible source of renewable energy. To this end, Singapore has set an ambitious goal of supplying 28% of its peak power demand through solar energy by 2030 and an even higher target of 43% by 2050. This will be achieved by implementing a large-scale deployment of building integrated photovoltaic and floating photovoltaic across the city-state. The construction industry is exploring ways to transform cities into urban forests that coexist with nature. Even greater creative development lies ahead. Very cool, right? Let's move on to the next section. In 2005, the Green Mark certification scheme was introduced to evaluate buildings for their environmental impact and performance. In 2021, to help Singapore further raise its built environment sustainability standards tailored for the tropical climate, a new BCA Green Mark 2021 scheme was announced. The criteria under the new scheme now have two categories: energy efficiency and sustainability. The sustainability section includes intelligence, health and well-being, whole life carbon, maintainability, and resilience. If you are working on a green building project, you will encounter some environmental indicators, as this slide shows. Have you ever seen any of them? The certification level is determined solely based on its energy efficiency. However, to address non-energy components, 5 sustainability sections have been developed. Depending on the overall assessment and point scoring, the building will be awarded a Green Mark rating to indicate its level of sustainability. It's important to note that there are separate certification schemes for new and existing buildings, as well as residential and non-residential buildings. There are surveys designed to facilitate different types of buildings in fulfilling their respective energy efficiency requirements. Pathway 1 using energy use intensity. Pathway 2 using fixed metrics. And Pathway 3 using energy modeling. All Green Mark buildings should also comply with the minimum regulatory requirements stipulated by other government agencies. These requirements form the base for a holistic green building and ensure that all sustainability angles are achieved. Now, let's take a moment to appreciate the inspiring evolution of sustainable design awareness. We come to the last section. The Sustainable Development Goals are in a broad range. Singapore understands the challenges of achieving them. Today, Singapore has achieved the remarkable feat of being recognized as the most sustainable city in Asia, with a remarkable global ranking of being in the top 10. This achievement is a testament to the city's unwavering commitment to environmental sustainability and its innovative solutions for creating a greener and more sustainable future. The Singapore Green Plan is a comprehensive national initiative that aims to promote sustainable development in Singapore. One key aspect of this plan is the Singapore Green Building Master Plan, which lays out the country's ambitious environmental sustainability goals for the built environment. Singapore, being a small and resource-limited country, relies heavily on imports to meet almost all of its energy needs. Piped natural gas is imported into Singapore from Indonesia and Malaysia. The interconnecting power grid in the region will further strengthen energy security and resilience. Additionally, Singapore is also exploring alternative sources of energy, such as developing solar farms in Australia and transmitting the energy back to Singapore for local use. In spite of Singapore's limited land, the country has managed to make the most of its underground space. Beneath the surface, there lies a vast network of infrastructure, such as pedestrian link, the common service panel, MRT and vehicle tunnel, the underground ammunition facility, the underground reservoirs, etc. Moreover, Singapore is on a mission to globally lead the way in digital transformation. And that brings us to the end. I'd like to thank you for your time and attention today.